Relative lowering of vapor pressure is given by this formula, where this is nothing but the mole fraction of solute. Mole fraction of solute can be approximated because N2 is very less than N1. N2 is negligible. Solute is negligible as compared to solvent. So in the denominator, N2 is neglected. And then number of moles of solute will be given mass over molar mass, and number of moles of solvent will be given mass upon molar mass. So you will usually use this formula if the values are given in mass and molar mass. Okay. Then I don't really remember whether we did this question or not. Just let me know whether this question was done. Okay, we did. Good. So we did this question. Now the next part. Elevation of boiling point means increasing in boiling point. How the boiling point is increased if we add the solute. So it is actually related to vapor pressure. As the vapor pressure is now low, and what is boiling point? Boiling point is the temperature at which the vapor pressure becomes equal to atmospheric pressure, means external pressure. Here it is atmospheric pressure I am calling it, because normally we have atmospheric pressure as the external pressure. This is actually external pressure. That is boiling point, that temperature. Now, if there are certain solute particles, these were yellow ones were solvent particles earlier. So it means to have the same vapor pressure equal to 1 atmospheric pressure. This is same. This has not changed. In initial case, it was 1 atm. Now also it is 1 atm. But in this case, vapor pressure is low. Vapor pressure is low because there are solute particles. So to make vapor pressure equal to 1 atm, we will have to provide more heat. More heat required to raise vapor pressure and make it equal to 1 atm, because at 1 atm vapor pressure it will start boiling. So now to boil the same thing, means earlier it was pure water, suppose now it is water solution, sugar solution say. So it will require greater amount of heat to have the vapor pressure equal to 1 atm. So that's why boiling point will increase. So elevation in boiling point due to addition of solute. So in order to make a solution boil, its vapor pressure must be increased to 1 atm. 1 atm is 1.013 bar external pressure, by raising the temperature above the boiling temperature of pure solvent water. So earlier it was 100 degrees Celsius. but now it will boil slightly greater than 100 degrees Celsius. So thus the boiling point of solution now is always higher than that of boiling point of pure solvent in which solution is prepared. So that is always. So there can be objective questions also where you need to remember this thing, that boiling point will always increase if something is added in pure solvent, and that is non-volatile. Okay, non-volatile solute is added. So we will not be talking about camphor, for example. Camphor is a solid which directly gets converted into vapor form. So camphor sublimes. So we will not be talking about that. We will be talking about non-volatile solutes only. So graphically, you can understand that initially, if we talk about that, we are increasing the temperature. When we increase the temperature, vapor pressure increases because more solvent will get vaporized. Solute will not get vaporized, that is solid. More solvent will get vaporized. But if it is pure, then there will be solvent only. Okay? And this will be the graph. Suppose this is the graph in case of solvent only. But if we have the solute also, so this is solution then. So in that case, the graph will be like this. Why? Now at higher temperature, TB, initially it was TB naught, pure solvent. TB naught is boiling temperature of pure solvent. Now to attain the same 1 atm level, this graph will cut the 1 atm here. It means the temperature required will be greater than TB naught, and that is denoted by delta TB. So delta TB increase in boiling point will be TB minus TB naught. So sometimes there will be, these type of graphical questions. Graphs will be given. You will be asked which particular one represents the correct phenomenon of elevation in boiling point. So you need to remember solvent will be at the top, solution will be beneath that, and then it will satisfy the condition of that 1 atm pressure will be reached, vapor pressure will be reached at higher temperature. Similar to lowering of vapor pressure, the elevation of boiling point also depends on the number of solute molecules rather than their nature. So all these are colligative properties. Colligative properties means they depend on the number of molecules, not the nature of the molecule. All four, depression in freezing point and osmotic pressure also, what we will be discussing, all depend on the number of solute particles, not the nature. So the elevation delta TB will be TB minus TB naught. This is the elevation in boiling point. Experiments have shown that the dilute solution for dilute solutions, the elevation of boiling point is directly proportional to molality of the solute. Okay. So remember, we are not proving it. Experiments have shown. So by experiment, we find elevation in boiling point is actually equal to the molality of the solution. So if we remove this proportionality constant, we get delta TB equals to KB into M. This KB is a constant which is known as boiling point elevation constant or molar elevation constant or ebullioscopic constant. It can appear in your exam with any of these three names. Okay. The constant of proportionality KB, this one is boiling point elevation constant, as there is elevation in boiling point. So that's why the name is straightforward, boiling point elevation constant. Or molar elevation constant because it is related to molality and it is elevation, so molar elevation constant or abelioscopic constant. Abelioscopic itself means related to boiling. This relationship you will be using in calculations. Delta TB equals to KBM. And it is very similar. The concept of elevation in boiling point and depression in freezing point, the formulas are just analogous. So if you just remember one, you can use the same formula for the other one. Just these subscript will change. Instead of boiling, for freezing, it will be F. The unit of KB is kilo kg per mole. Sorry, Kelvin kg per mole. So even if you don't remember this, you can get it by here. Delta TB divided by molality. And you know that delta TB will be Kelvin and molality is given by mole per kg. Mole divided by kg. When you simplify, it will be Kelvin kg per mole. If W2 gram of solute of molar mass M2 is dissolved in W1 gram of solvent, then molality M of the solution is given by number of moles of the solute divided by mass of solvent in kg. Okay, molality is moles of solute divided by mass of solvent. Mass of solvent is W1, but in kg, it will be W1 divided by 1000. So from here, you got molality equals to 1000 into W2 divided by M2 into W1. So this value actually you have got and you will be using it in that formula now. Substitute this value here and you will get delta TB equals to KB into M. This is M, small m you have calculated. This formula you will be using in calculations. So when question appears, this is the formula. If parameters are given, say mass of solute, mass of solvent, everything. So any one will be asked. Normally, it will be asked that how much it will increase or new boiling point. New boiling point will be initial boiling point plus change in boiling point. The new boiling point will be this one. So for example, for water solution, it will be 100 for pure water plus whatever is the increased delta TB. That will be the new boiling point. So the question is, the boiling point of benzene is 353.27 Kelvin when 1.80 gram of a non-volatile solute, remember it is always non-volatile in this case, okay, was dissolved in 90 gram of benzene. So benzene here is solvent, means it is first part, solvent. And solvent mass means W1 is 90 grams and W2 is 1.80 gram. This is solute means 2. The boiling point is raised by this much, means delta TB is given. TB raised 2, sorry, not delta TB, TB is given. TB 354.11 and initially TB naught was 353.23 Kelvin. So of pure solvent, it was 353.23. For solution, that is TB, if you remember in the graph, This one was given as 353 point something, and new TB is 354 point something. Their difference will be delta TB. Okay. Calculate the molar mass of the solute, means M2 is to be calculated. Kb is given. Okay. And you need to focus sometimes on the units of Kb. Sometimes it might be different. You need to convert it into Kelvin kg per mole. So apply the formula which we had obtained here, and you need to memorize this formula. Delta TB equals to Kb into 1000 into W2 by M2 into W1. Remember, all the masses are in grams. That's why 1000 is written there. Okay. So delta TB is equal to Kb into 1000 into W2 by M2 into W1. Substitute all the values. Delta TB is 354.11 minus 353.23. Okay, TB minus TB naught, the difference in temperature. KB is 2.53 in 2000 into W2 is 1.80 divided by M2, you have to calculate. W1 is 90. Substitute all the values and you get the answer as, so delta TB is actually the difference you will get 0.88, 354 point something minus 353 point something, and you will get the answer. Okay, Mac and Ashi, your answer is correct. So it is just application of the formula. If you know what is M1, what is M2, what is W1, what is W2, what is delta TB, what is delta TB not, these things you need to identify, and that's what I'm emphasizing on. That is the common mistake that students sometimes make mistake, that they get confused between W1 and W2, 1 and 2. That is the common mistake. M2 here is molar mass of solute. Anything related to 2 is related to solute, Varsha. Okay. So second part is solute, first part is solvent. W is mass. So W1 is mass of solvent. W2 is mass of solute. Capital M is molar mass. M1 molar mass of solvent. M2 molar mass of solute. Okay. So it will be slightly, I think, let me check answer. uh-huh. 2.53 into 1000 is 1.8 divided by 0.88 divided by 90. Yeah, so it is, Ashi Mac had given correct 57.5. Shashwat, yes, 57.5. So it is close, correct. Ahan, your approximate answer 60 is correct. Okay. Okay, now depression of freezing point. It is very similar to elevation in boiling point. Okay. Freezing point is depressed. Okay. Similar to elevation of boiling point, depression of freezing point, that is delta TF. F for freezing. For dilute solution, it is again proportional to molality. And here the constant of proportionality is Kf instead of Kb, Kf. And it is known as freezing point depression constant, which is straightforward. It is related to freezing. That's why freezing point. It is lower than the previous one. That's why depression constant or molal depression constant. Remember, in case of Kb, it was molal elevation constant. Here it is molal depression constant or cryoscopic constant. Cryoscopic itself means the word cryogenic, cryoscopic. These means which are related to very low temperature. So if you opt for engineering, then if you opt for, the mm, mechanical engineering also, if those actually study about the cryogenic engines which operate at very low temperatures, which can operate at very low temperature. The unit is again same Kelvin kg per mole because Kf will be equal to delta Tf divided by molality. The unit is same for both Kb and Kf. And similar to what we talked about in case of boiling point elevation, W2 gram of solute of molar mass M2 is dissolved in W1 grams of solvent, then molality M will be given by number of moles of solute divided by mass of solvent in kg. When you substitute, you get delta TF equals to KF 1000 W2 by M2 into W1. The only difference is that instead of B, now here we have F. So in both cases, formulas are similar. The values of Kf and Kb, which depend upon the nature of the solvent, can be ascertained from the following relations. Okay. Remember, it is written nature of solvent, not nature of solute. Okay. That's why we are talking about colligative properties. These do not depend on the number of, sorry, these do not depend on the nature of solute particles, rather only the number of solute particles. So this is how these are given if we are talking about only Kf and Kb not related to CBSE, only for those who are planning for NEET and JEE main. All parameters have their usual meaning. R is gas constant, which is the same, but it is gas constant used here. M1, M2 molar masses. So M1 is molar mass of solvent. TFTB freezing point, boiling point. Delta H fusion, heat of fusion, delta vaporization, heat of vaporization. So there can be direct formula based questions in JEE and NEET both. So for that you need to remember, for CBSE you can skip it. Next question. 45 gram of ethylene glycol is mixed with 600 gram of water. Calculate the freezing point depression, the freezing point of the solution. Solve it and tell me the answer in your notebook. Solve it. Okay, one answer received. Ashish, let me check. 45. Looks close, yes. Ashi, correct. One. Just let me check. Tell me B part also. First, if you are writing both, just write A and B. Okay. Mehak, uh, that is actually A part, Mehak. Vandana, A part will be, okay, you have written K there. Okay, fine. A part approximately correct, Vandana, Mehak. As I said, that is actually A part, what you have answered as B. Yastika, yes, correct. Shashwat, no, try again. I'll tell you. It is written water, Ashi, 600 gram of water. So solvent is water. You know the boiling point of water, or freezing point of water in this case. Okay, this much time is sufficient. So if you see, ethylene glycol is mixed with 600 grams of water. So water here is solvent. So W1 600 grams, W2 45 grams. And molar mass of the solute, that is M2, will be 2 into 12 plus 6 plus 2 into 16, that is 62. Okay. Or in, if we talk about molar mass, gram per mole. Now we know that delta TF is equal to KF into 1000 into W2 divided by M2 into W1. Substitute the values. W2 is 45 and M2 we have calculated 62, W1 600. When you solve this one, you will get 2.25. Yeah, that is the freezing point depression. Means this much decrease will be there in freezing point. Freezing point depression means this much decrease, delta T. Then the freezing point of the solution. So freezing point of water was 0 degrees Celsius, effectively 273.15 Kelvin. So delta TF is actually TF, which was earlier, minus TF naught. Okay, because it is depression, then you will write the new one is less. So write TF naught minus TF. Why I have written like this? Because earlier, suppose it was 0 degrees Celsius, then solution will have less than 0 degrees Celsius. So delta TF will be TF naught minus TF, which is you have calculated as 2.25 Kelvin. Okay. TF naught is 273.15 Kelvin, minus TF equals to 2.25 Kelvin. So from here you will get TF equals to 273.15 minus 2.25 Kelvin. Yeah, depression. So depression means it will be less than the freezing point of solvent. So 2 points you have to remember, and the direct questions can be there, objective type questions, that the boiling point of the solution will always be greater than that of pure solvent. Boiling point of solution, say sugar solution, will always be greater than the boiling point of pure solvent, that is water. So greater. That's why elevation is written there. Freezing point of solution will always be less than that of pure solvent. So that's why depression is written here. So if your answer, for example, is you are getting greater than 273.15, it means there is something wrong. If boiling point, suppose we are talking about water solution, if the boiling point of solution comes out to be less than 100 degrees Celsius or 373.15 Kelvin, it means there is some mistake. It should be greater than that boiling point. Freezing point should be less than pure. Yes, sir. So that's what I have already told you, that initially students make those mistakes and remain confused, and practice actually makes it clear. So initially you will remain confused with W1 and W2 because that's what we have done till now, till 11th grade, not only 10th grade, till even 11th grade, we considered W1 as solute and W2 as solvent. And here it is opposite. So it's 2.25. This is some calculation done here. That's why we are getting 2.232. And you will get approximately 270.918. One important point here, that in many questions, specifically in JEE and NEET, this value will not be given. You need to remember. AF for water is 1.86 and KB for water is 0.52. We will talk about that, okay? 1.86. This value, even if not given, you are expected to remember for water, not for other solvents, for water only. Next question. 1 gram of a non-electrolytic solution dissolved in 50 grams of benzene. So this one is solute, sorry, W2, and this one is solvent, W1. Benzene is solvent. Lower the freezing point of benzene by this much, means delta TF is given. 0.40. Lowered the freezing point by the freezing point depression constant of benzene is given, Kf is given for benzene 5.12 Kelvin kg per mole. Find the molar mass of the solute. W2 is given 1 gram, W1 is given 50. You just need to substitute the values. The point here is that, and that is important point, okay, that you first convert the formula in terms of molar mass. I have seen teachers deducting marks, even though it is 100% right that you write the formula for Kf, sorry, delta TB or delta TF in this case, Kf into 1000 into W2 divided by M2 into W. That is absolutely fine. And substitute the values and get M2. But teachers need in many schools I have seen that you write it like this. Kf into 1000 into W2 divided by delta TF into W1. So if molar mass is asked, write formula in this form, not in the above form. For me, both are correct. And the logic behind these, this thing that why teachers have deducted marks in exam, what students have told me that their logic was that NCRT has given these two formulas separately. NCRT has written this formula and this formula also. So for delta TF, NCRT has written this formula for molar mass, this formula. So they say no, because it is written in NCRT as this formula, you have to use this formula. However, both formulas are same. Okay. So when you substitute the values, you will get the answer. Now let me see Vanna Shashwat Ashi correct. Mehak, you are close. Might be some calculation difference. Okay. Now the last part, osmosis and osmotic pressure related to the colligative properties. So we are talking about colligative properties. Okay. The third part we have talked about depression in freezing point. The first part was relative lowering in vapor pressure, colligative property. Then elevation in boiling point, then depression in freezing point. Last one we are talking about osmosis and osmotic pressure. So first we need to understand when we talk about the osmotic pressure, what is osmosis and what is osmotic pressure. So we have this type of arrangement. In one side, right hand side here, we have pure solvent, say pure water. And here we have solution, say sugar solution, sugar plus water. And in between, we have a semi-permeable membrane. Semi-permeable membrane means it allows only the solvent particles to pass through it. Allows only solvent particles to pass through it. Okay. So what actually will happen if there is no semi-permeable membrane? These two will get mixed. These two liquids will get mixed. Okay. And we will have same amount of solute and solvent in both the beakers. But here what happens, because this semi-permeable membrane allows only solvent particles to move. So only solvent particles can move in this direction and they will start moving. Okay? And initially, we have 1 atm pressure on both sides, atmospheric pressure on both the sides, 1 atm. So if pressure is same, then solvent particles will move towards the solution. Why? These will move because the system will try to decrease the density or increase the density. Means system will try to have the same density of the entire solution. Means in both beakers, in both sides. But the solute particles cannot move towards right. Semi-permeable membrane will not allow that. The size of solute particles is normally greater than solvent particles. So it will not allow solute to pass through it. So solvent particles will move from right to left so that they can decrease the density. So here density is higher, higher density of the solute. System will try to decrease it. So solvent particles will move in the left vessel or jar or beaker. Now, if we apply excess pressure here, pi, excess pressure on the left chamber, and that pressure is exactly when this movement of the solvent to the left chamber stops. So if we increase the pressure here, when we increase the pressure, it will exert pressure here and it will decrease the amount of or rate of the solvent passing from right chamber to left chamber. So at that pressure, the pressure, this one, pi, at which the movement of solvent particles stops, just stops, is known as osmotic pressure. Osmotic pressure is equal to that pressure which stops the movement of solvent particles from solvent side to solution side. Now come to reverse osmosis. Reverse osmosis is that we increase this pressure greater than atmospheric osmosis pressure. So if we further increase this, further increase means greater than pi. Pi is osmotic pressure. Okay? So pi, osmotic pressure, the pressure which stops the osmosis. So if it is greater than pi, then what happens that solvent particles from the solution, not solute, only solvent, from the solution start moving into the right chamber. Now it is reverse process because here in the solution we have solute plus solvent. So this solvent starts moving to the right side because semi-permeable membrane will allow only the solvent particles to pass through it. Due to higher pressure, now it will be from left chamber to right one. This is the process which is used in RO system, reverse osmosis system, to purify water. These solutes are impurities in that case. Solutes are impurities. When excess pressure is applied greater than osmotic pressure, then pure water passes to the solvent chamber, and this is where you get the water from the RO system. This chamber is that chamber where you store the water in RO system. That's why it is called reverse osmosis, because it actually reverses the osmosis process. Anything not clear, let me know. No. So the osmotic pressure of the solution is the excess pressure. Excess pressure means greater than 1 atm. This is excess pressure, additional pressure you are applying. That must be applied to a solution. You see, we had applied it to a solution side to prevent osmosis or stop osmosis. Stop the passage of solvent molecules through a semi-permeable membrane into the solution. Osmotic pressure is proportional to the molarity C of the solution. So here C, remember, is molarity, not written as M. It is written as C, which is number of moles divided by volume. So if you see it analogous to gas law, PV equals to nRT. Remember, it is analogous, but it is not exactly same thing because here there is no gas. We are not talking about gases. But because we are talking about pressure, so it is analogous to that one. And it is PV equals to nRT. So pressure will be N by V RT. And what is N by V? Number of moles divided by volume of the solution. This is molarity. So it is written P equals to CRT. P is written as pi here. Pi equals to CRT you will be using to calculate the osmotic pressure. V is the volume of the solution in liters, okay, containing N2 moles of solute. Why we have written N2? Because solute is treated as 2, second part. That's why. Two solutions having same osmotic pressure at a given temperature are called isotonic solutions. If we have two different solutions, but they have same osmotic pressure, then we will call those as isotonic solutions. This appears as easy questions in objective type. Then reverse osmosis and water purification. This is something I have explained that you now apply pressure greater than osmotic pressure at the solution side, means salty water or impure water. So it actually reverses semi-permeable membrane. Now the solvent, that is water, pure water, passes from solution side to solvent side. This is solution, this is pure solvent. The process reversed, that's why reverse osmosis. Now the question, and this question is something you have already done based on that concept. Boiling point of water at 750 mmHg is 99.63 degrees Celsius. How much sucrose is to be added to 500 grams of water such that it boils at 100 degrees Celsius? Kb, although here it is given 0.52, but you need to remember Kf 1.86, Kb 0.52 for water. It is not given, you need to use. Okay, so tell me the answer in this case. You need to calculate the amount of sucrose which needs to be added. Means W2, W2 you have to obtain. Okay. She, what molar mass did you consider? What was the molar mass? No. For sucrose, it is 342. She write the values in terms of just if you write W2 equals to that, write the values and without solving, I want to know what values you have considered. Yes, now correct answer. Others, I am waiting for answer. This much is more than sufficient time. Okay, because you know that delta TB. Okay, in this case, this pressure does not matter. This is external pressure. Instead of 760, it is 750. So might be we are talking about at at mountains, hills, etc. So delta TB will be equal to KB into 1000 to W2 divided by M2 into W1. So from here, W2 will be delta TB into M2 into W1 divided by KB into 1000. That is 0.52 into molar mass of sucrose 342 into W1, that is mass of solvent 500 grams, divided by KB, sorry, it is delta TB, not KB. It is 100 minus 99.63 into 342. Here it is KB into 1000. So delta TB is 100 minus 99.63, what I have written here. Okay. 100 minus 99.63 into 342 into 500. When you solve this one, you will get 121 approximately 0.67 grams. Yes, Armina, correct. Next, calculate the mass of ascorbic acid to be dissolved in 75 gram of acetic acid to lower its melting point by 1.5 degrees Celsius. Remember, melting point is just reverse of freezing point. Melting point is just opposite of freezing point. You are moving in reverse direction. That's it. Otherwise, melting point and freezing point is same. Yes, one previous answer was correct. Now solve this one. Mass of ascorbic acid to be dissolved in 75 grams of acetic acid. Acetic acid is solvent 1. Ashi, correct. Mahak, there is some calculation mistake. Armina, correct. Shashwat, yes, approximately correct. Vanna, correct. So look here. Basically, melting is analogous to freezing. It is just opposite. Solid to liquid is melting. Liquid to solid is freezing, but it will be at the same temperature. So you will say delta TF equals to KF into 1000 into W2 divided by M2 into W1. So from here, W2 will be equals to delta TF into M2 into W1 divided by KF into 1. That is 1.5. So if it is 1.5 degree Celsius difference, it will be 1.5 Kelvin also, because you just add 273 in both. 273 and 273 will get cancelled. Into M2, molar mass, if you calculate this one, you will get 176, and W1 is given 75 divided by KF given 3.9 into 1000. When you solve this one, you will get approximately 5.07 grams. Okay, now solve this question. Calculate the osmotic pressure in pascals exerted by a solution prepared by dissolving 1 gram of polymer of molar mass, this much, in 450 ml of water at 37 degrees Celsius. There is nothing you don't know. You have to calculate pi. Pi equals to CRT. You know the mass of the solute, which is polymer in this case. You know the volume of water in milliliter. You can convert it into liters. You can get the temperature is given, and value of R you know. And you know the formula as well. Solve it in your copy. Ashwat, there seems to be some calculation mistake. Ashi, okay, calculation is correct. Okay, Vandana, correct. Uh, what you have taken the value of R, Vandana, right in the chat box. So, Hina, uh, what is the value of R you have taken? Your answer is correct. Varna, your answer is correct. Just tell me what is the value of R you have taken. Okay. One that won't give you that answer. That won't give you that answer. The answer is 31 Pascal approximately. And basically, when you are getting the answer in Pascal, the value of R you need to consider as 8.314 into 10 to the power 3. Okay. So if we talked about, say, remember in energy, we use this one, then we said that value of R is 8.314 if we are considering in joule. If we are talking about in ATM liter, then 0.0821. If we are talking about bar liter, then 0.0831. But if it is in Pascal, R is 8.314 into 10 power 3. So pi is CRT. CRT. Means C is number of moles of solute divided by volume of solution RT. Number of moles of solute is nothing but W2 by M2 divided by V RT. That is W2 RT divided by M2 V. Okay. Yes, Ashi. So W2 here is given solute 1 into R 8.314 into 10 to the power 3 into temperature 273 plus 37 310 divided by M2 1,85,000 into volume in liter. It is in milliliter. In liters, it will be 0.450. When you solve it, you will get around 30.9 something, which is approximately 31 Pascal.